Welcome back to my channel, everyone. My name is Tyler, and today we're going to be implementing object literals inside of our programming language. So currently, we cannot support anything like this, but by the end of this episode, we'll be able to create some code like this and actually be able to get a valid AST from it. And in the next episode, we'll work on actually implementing runtime support for it. So currently I just created a test.txt file that we can actually test our program in. And then I refactored the REPL, or I didn't refactor it. I created a new function that will allow us to actually just run the file, and it'll just use Deno's read text file to read the file and run the program, so we don't have to worry about messing up in the REPL because there's a lot of mistakes with objects to mess up. But before we get into that, I wanted to implement the environments, right? So currently we're just kind of hard coding these values, and I really think we can do it a lot better. So I'm going to just get rid of the default values in both scopes, right? So I'm going to just copy that, get rid of it, and now let's actually go ahead and implement in our environment a function, setup global scope, right? And it's going to take in the scope like so, which is going to be an environment. And actually, it's just going to be called setup scope because we want to be able to use this for other things later. And instead of calling it scope, I'm actually just going to call it env. And we're going to add all of the missing imports that we need. And there we go. This is basically all this is going to do. It's going to take in our environment, which is a reference, so we'll be able to mutate it, right? It's not a copy, it's a reference in JavaScript. So if you're using another language, you want to pass by pointer or something like that. But this is a reference, so we can just mutate the variables, declare the scope, and then in here in our constructor, right, if the parent is not set, so what we're going to do is we are going to have a let or a const env global is equal to parents env. If it's set, it'll be true, else it'll be false, like so. And I didn't mean to do that, I meant to do a question mark. There we go. So global is going to just basically be, hey, if our parent environment was passed in, right, it's going to be true, false, otherwise. And all we're going to do is if global, we're just going to do setup scope, and we're going to pass in our this dot. Sorry, what are we going to do? We're going to pass in this. There we go. So we're going to pass in our scope, and now we can actually have a simple looking runtime that looks like this. No need to worry about the environment. We can just set them up right here. And in the future, we'll add functions and other things in here. Okay, there we go. Enough environment stuff. Let's actually get into objects. So inside of the Lexer, let's go ahead and define a few tokens we're going to need, right? Because we don't have support for, what's it called? The left bracket or left brace and the right brace, as well as the comma and colon. So we're going to need access to comma, colon, L. We'll actually define it down here by the open and close paren. We'll have open brace and close brace, like so. So there we go. And I'm just going to put a comment because I always get confused which one's a brace and which one's a bracket. That's close paren, which we don't really need to comment, but I'll just do that. And there we go. So now that we have these two tokens as well as these two, we need to add support for them in our tokenizer. So I'm going to just copy these two, this line of code twice, and this will be for support for our open, right? So open brace, then this will be our close brace, and we're going to add the same thing, close brace, like so. So that looks good there. Then we need to add support for semicolon and commas. So I'm going to copy this twice, and we're going to add support for a comma, or colon, sorry. So this is just going to be of type colon, and this is going to be of type comma. And there we go. Now we have support for these new operators that we can use in our AST. Speaking of the AST, let's now go ahead and actually add our AST node that we need. So we need to declare a new node. And actually, we need to declare two new nodes. We need to declare these are going to be literal types. So I'm going to come down here and say literals. We're going to declare a node for a property. as well as declare a node for a object, right? Which is going to contain, as you guessed it, properties. So these are two literals right here. So now let's go ahead and define these. Now I'm going to just copy this line of code right here and build off of it. So here we're going to have an object literal, right? An object literal, which is basically going to do the same thing. It's going to be of type object literal, and I already realized I didn't say it was a literal. There we go. So we have an object literal. What is an object literal? Well, it is simply just an array of objects. So it's going to be the properties is going to be a property, ERTY, array, like so. Now we don't have a property type defined, so I'm going to just copy this, come up above, and paste in the type for a property. A property is going to be of type property, right? And a property has two fields. It has a key, which is always a string, always, and a value, which is going to be an exper, like so. However, we do want to handle the case where the value, right, is not passed in, right? We want to be able to support a shorthands like this, where you can do key, colon, key, or you can just type key if the variable name's the same. To do this, we're going to say this is an optional value, like so. And there we go. Now we have what we need. So let's actually now go ahead and add this into our parser support. So let's go to the parser right here. And inside of the parser, we're going to want to add a parse object expression function right after parse exper, right? So right here, we do parse assignment expression. Then what we want to do is we're actually going to want to actually handle objects, right? So instead of calling parse additive, we're going to call parse object exper, like so. There we go. So now we can get rid of that comment, like so. And now let's add this function. So let's do declare method. Beautiful. And let me also make sure these are private, because I didn't think I added the case specifier last time. There we go. Okay, cool. So now we have parse object exper, like so. So parse assignment is going to call into that. And then also assignee is incompatible with type parse assignment. Yeah, that's fine. Okay, cool. So now we have this parse object expression. Let's go ahead and add the return type of expression. We're just going to hard code it like so. And now what we want to do is implement this. Okay, so there's a lot to this. What we first expect, though, is something along the lines of object followed by a closing with an array of props, right? So let's kind of think how we want to define this, right? So thinking about the grammar, what we would expect is if the this.adds type is not equal to a token type.open brace, right? If we're not at an open brace, then we're just going to continue through. We're just going to parse additive, right? So we're going to return this.parse additive exper, like so, right? If we're not at an open brace, then no need to even worry about this. We continue through. However, if we are at an open brace, right, what we want to do is we do this.eats. So this advances past open brace. Perfect. Okay, so now that we're past the open brace, right, what we want to do is define our array of properties. So I'm going to do const properties is equal to a new array of property, like so. Beautiful. So now we have this array of properties that we can kind of iteratively add on to. What I want to do is we're going to do a while loop. So we're going to do while, not EOF, right? So while we're not at the end of the file, and while the this.at, so while our current token dot type is not equal to a token type dot close brace, right? So currently, we've already eaten the open brace, right? So now we want to iteratively keep going through until we do not have a closing brace. Okay, so that should make sense. Like so. Now, let's actually go ahead and then at the very bottom, let's do this.expects token type dot close brace expects object missing closing brace, like so. So now we're gonna just basically do it like this. Okay, so now we have our object right here, and all we have to do is do return boom as in object expr, and I'm typing terribly right now. Right, so as an object, as in object literal, sorry. What we're gonna do is we're gonna say the kind is object literal, and the properties is like so. Okay, so now we have everything we need except for the key value pairs. So there are three cases we can handle. We can handle something where it's like key, colon, val, right? Then there's an optional comma right here. And then another key 2, comma, val. However, there is the option for something like key, comma, or key, right? So we want to be able to handle all these kind of cases. So let's actually now go ahead and begin actually parsing this out. So first things first, we know we have a key. So const key is equal to this dot parse. And what we want to do is we want to parse expecting a key. So what we're going to do is we're going to do this dot expect token type dot identifier, right? Object literal key expected, right? So this is going to be the key of type token. So what we're going to do is we're going to get the value like so, and now we have the actual string for our key. Cool. So now that we have the key, what we want to do is we're going to want to check if our current type is of a comma, right? So if we have our shorthand syntax, if this dot ats dot type is equal to token, oh my, token type dot comma, right? So if we're at a comma, what we want to do is we want to do a this dot advance, or sorry, eats. So we're going to advance past the comma, and then what we want to do is we want to push back our new property. So what we're going to do is we're going to do this dot, not this, sorry. Oh my gosh, properties dot push. What we're going to do is we're going to push a new, not new, sorry, we're just going to push as property right here. And what are we going to do? We're going to push the key like so. The kind we already know is a property, and the value, right, is undefined, right? Because we don't have a value. This is a shorthand. So we'll deal with the value when we actually get into the runtime in the next episode. So we're done, right? We can push the property, but we need to make sure we call continue, so that way we don't, continue through. Okay, so now we've handled the shorthand. So this allows shorthands key, comma, pair, right? Just becoming key, like so. Okay, so now we've handled that. What we now want to be able to do is handle the shorthands just like this, but what if they didn't do a comma? What if they just did this? What if this is all they entered, right? Currently, this supports this, but what if they don't actually pass a comma? So let's handle that as well. Like so. So now we're going to copy this. We're going to add our else if this time we're at token type of R, not R, it's not right, it's a closing brace, right? So now if we're at a closing brace, we're going to do the same thing, except we're not going to eat the token, like so. And there we go. Now we can push on a new property, and this is going to allow users to do just key, like so. So now we've handled 2 of the 3 cases. Now what we want to do is handle the colon, followed by a value, followed by an optional comma, right? Because they could only enter something like this. So now let's handle this support right here. So I'm going to actually come down here, and we're going to say we want to support this now. So what do we do to support this, right? Well, at this very moment in time, we expect that there's a comma, or colon, right? So we're going to do this dot expect token type dot colon, right? Missing colon following in an object expr. Cool. So we expect the colon, And then we expect a value to be following it. So constant value is equal to this dot parse. And what we're going to want to do for the value is we're going to parse an expression, right? Why an expression? Well, you can think that we want to allow basically any expression to be on the right-hand side, whether that be another object, an assignment, a call expression, right? Anything like that. So now we actually parse out the value. Cool. So now that we have the value and we've gone past the colon, there's two kind of cases, right? We could get to another key value pair. We could also have a comma, and we could not have a comma. So I guess that's 3, right? So what we want to do is we are going to actually check if, right? Well, I guess first we'll actually want to push. We'll do properties.push, right? We are going to do the kind is of type property. The value is of type value. And the key is of type key. I also just realized we can get rid of this right here, like so. So what we want to do is we want to push our new key value pair, right? We want to push it. And then what we want to do is check if this dot at is at a right brace. So this dot at dot type is equal to, right? So while we're not equal to, sorry, a token type dot close brace or right brace, right? While we're not there, we expect to find a comma. So this dot expects token type dot comma. Expected comma or following property, right? And there we go. Now we can actually, I don't know why I'm capitalizing everything. There we go. And now we can handle, hey, if they entered a key value pair and say they entered a dot or some random character, we'd be like, what is this, right? Cool. So now what we can do is we're done. We've actually now parsed the entirety of this object literal, like so. So we're literally done with that. Now we can actually go ahead and test this out and see if it works. So let's go ahead and do that. Let's come in here, ls clear. And what we're going to do is we're going to do a quick deno run -a because I don't want to type the security flags. I'm going to do main.ts. There we go. Okay, so we get unrecognized character found in source. Ah, yes. The unrecognized character is because I didn't actually specify the character for these two right here. I put them as a brace. They needed to be a bracket, right? So let's actually fix that. Brace. Yep, that is a brace. And this is a bracket. There we go. Okay, now we can actually run this. Unexpected character found in source. Character, what was this? 13. What is character 13? Is that a new line character? Let's see what character code 13 is. We're going to kind of debug this together. So let's do ASCII table. Okay, let's see what character code 13 is. So we can kind of debug this. What is it? It is a carriage return. Ah, yes, it is. So what we actually want to do, right, is handle the carriage returns as well in our is skippable. We want to be able to handle or str is equal to \r, right, for our carriage return. And there we go, right? So now we have a type of object literal, and we can see this works. We have a properties array attached to this object literal. We get a kind of property, a value, which has a kind of numeric literal, and a key of x. X is 100, y is 32, and look at this. We get a property with a key of complex and a value of another object literal. So we can see that this works. X is 100, y, foo should be equal to undefined. Let's quickly check. Foo is equal to kind foo. So yeah, this seems to be working. This is really cool. So now we can actually use this inside of our evaluator. I said in the next episode we would go ahead and implement the evaluator, but I actually kind of want to implement it now since it isn't very complex. And yeah, let's go ahead and actually add support for our evaluator. Okay, so we're going to need to create a new type for our runtime. So inside of the runtime folder in the values.ts, we currently have support for null, numerics, and booleans. Let's add a new type, and this is going to be for type objects. Right, so we have a type of object. Nice. Now let's create a new helper functions like this. So we're going to create a number val. Instead, we're going to call it an object value. We're going to have, we're not going to have a helper for making an object, but an object value, all it is it contains a type of object and a value, right? We don't even need, we just need the properties. Prop, E-R-T-I-E-S, is going to be a record, right, of type, actually we could just do it like this. It's of type map to a string, comma, and we have what? Runtime values, like so. So this is how we can define our object, right? All an object is a properties field, which is going to contain a key and a value pair. In a runtime value, it could be any type, right? It could be a function, it could be a value, it could be another object, etc. So there we go. Now we have support for our object val. Let's go ahead and actually implement this inside of our evaluation. So inside of the expressions.ts, let's minimize this, right here. And then right by this eval identifier is where I kind of want to do this. So what we're going to do is we're going to do exports function eval of objects exper like so. Okay, and what does it take in? Well, it takes in the object, which is of type objects literal. It takes in the current environment as well, and it returns a runtime value like so. Okay, so now that we have this function declared, let's actually go ahead and inside of our interpreter.ts, add it real quick. So if the case is identifier, right underneath that, we're going to do case is an object literal. We're going to do return eval object exper, and we're going to pass in the AST node as an objects literal, and then the current environment like so. Okay, so that seems to be just what we want. Now let's actually go ahead and implement the logic for our for our objects. So let's now go ahead and get this all set up. Okay, so to evaluate an object, right, what we want to do is we want to create a type for our object. I'm just going to go ahead and do this, and I'm just going to call it object is of type objects, which is going to be the type is going to be an object, object, and the properties is going to be a new map of string. We can actually just call new map like so and say this is of type objects val, right? So here's our object that we actually want to append properties onto. And then we're just going to return objects down here. Okay, so now let's actually get started implementing our object. So what we know is that our object, like obj, right? So obj dot, it has a properties field right here. And this properties field contains the individual property. So what we're going to do is we're going to do for const prop of, and what we're going to do, because properties is an array of props, right? We're going to do for const key value of object.properties. So now we have access to the key, which is a string, and the value, which is an expression, or it could be undefined, right? So now what we want to do is we want to translate that into a properties right here. However, this properties has to do with a map, right, of runtime values, not a map of strings. So let's actually go ahead and implement this. So what we're going to do is we're going to do if value, right? So that means this handles the valid key colon pair, right? So this is going to be handling that. So if there's a value, what we want to do is we want to do not properties, sorry. We want to do objects.properties.set. We're going to have the key, like so. And then we're going to pass the value, like so. And value, though, is going to be of that. So we're going to call it runtime val. And instead of actually doing it in here, let's actually create this in here. So instead of doing an if check, we're just going to do const runtime val is equal to, we're going to do value is equal to undefined. If it's undefined, what we're going to do is we're going to say evaluates, right? The AST node in this case is going to be, what type is the AST node going to be? What we want to do is, that's what we want to do. We want to do env.x, we want to look up our variable of the key, right? So we're going to do key. Else, then what we want to do is we want to evaluate the value, like so. And we pass in E and V. There we go. So this is how we're going to get our runtime value, right? What's this doing? This is saying, hey, if the value is undefined, aka if someone did our shorthand, right? They did key, well, let's just say they did this, right? Foo. What this is the same thing as is foo is equal to foo. So we expect that foo is already defined in our parent scope. So we'll do it like so. We'll look up the variable. If this doesn't exist, it'll actually throw our error in the resolve function. And then if the value is defined but it's an expression, then we need to actually evaluate that expression recursively, and we get access to the value. And now we have our object.properties.set key and our runtime value, like so. And now we actually have an eval object expression working just like that. So that is how we can evaluate our object expressions, like so. Let's actually give this a quick test just to verify that this works. So let me view a problem. I don't know what that's coming from. Okay, that's fine. So what we're going to do is open up terminal. We're going to do dino run main.ts, and we're going to pass in -a right here. Okay, okay, here we go. And this is the exact error we would expect to get, right? Uncaught, cannot resolve foo as it does not exist. Oh, did I call eval? I think I did. Somewhere in here. Let me view that error, because that actually is helping us. No value exists in scope for the shorthand property foo. That's not what we want. We want uncaught and promise cannot resolve foo. So let's kind of see where this is coming from. Here we get our input, right? And then we do evaluate our environment. So let me log out the program. Just make sure we're actually getting this correctly. Yep, we do get our program. The identifier is an object, right? So clearly we're getting past that stage. Cool, so now let's go into our evaluate block and make sure we actually imported our object expression. We did, good. So we get case of numeric literal, number, good. Object, case of object, right? We do eval object expr. We pass in our AST node. Let's see what this is doing. Let's actually just console.log. Console.log. Not in here. Let's actually log every key in value. So console.log key value, like so. And let's kind of just quickly see what's happening here. And we get foo is undefined. Oh, I don't know why I was expecting, this isn't actually an issue. The error is uncaught, cannot resolve foo as it does not exist. Yeah, this is the error we created, not a JavaScript error. I have no clue why I was thinking it was. Sorry about that. Okay, so what we're going to do, right, is we were actually fine. This is exactly what we want. It's because we haven't declared foo before. Let's come up here and declare it. So just do const foo is equal to 45 divided by 2. I didn't mean to open that. Let's now give this code a quick run again. And we see uncaught in promise cannot resolve true as it does not exist. Yes, 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 more debugging. Let's go into our environment.ts. And in here we have our setup scope. Instead of actually passing in the scope, let's go ahead and do const env is equal to a new environments. And what we're going to do is we're just going to return env like so. And there we go. So now what we're going to do is instead of that, we're going to do const this dot parents is equal to that. So what we're going to do is instead we're going to call it create global env. Environments. Oh my god, I totally did not spell that. I'm just going to call it global env. And we're going to export this function for use inside of our main. Okay, so what we're going to do is in our main, we're going to do environments is equal to create global environments like so. And I'm going to copy this before I forget for our REPL for later. There we go. Okay, now this should all be working as expected. So we run it, and sure enough, this is what we get. And this is really cool, right? We can see that we have a type of objects, a properties, which is a map of x, goes to a value of 100, y, foo goes to a value of 22.5, right? Because it realized foo is shorthand for foo, like so. Sure enough, it is shorthand, as we can see, and complex is its own type, like so. Now, one thing you'll notice is that this prints using JavaScript based in, right? If you're writing this in a language like C, C++, etc., where you actually need to pretty print this yourself, you can actually, you'll have to define a custom recursive printing method, just like your AST, right? But here it prints using the basic types. So if you don't want it to say map, or maybe you just want complex to say like, maybe if you want this to look a little bit cleaner, you would have to define your own printing method. But that's besides the point. This is working as expected, which means now in the next episode, we'll be able to do something like this. We will actually have support for doing like prints. Or actually, we won't add that support just yet. What we'll do is we'll have like let's f is equal to object.complex.var, right? So we'll actually have support for this, and we'll see that f will be of type true. So let's just run it and verify it doesn't work. It won't. And there we go. Unrecognized character found in source dot. So in the next episode, we'll implement member expressions. So I hope to see you there. I'll talk to you guys later.